lecture A, system calls part 2.
Are we having
Oh,
are we having lab after this?
Yeah,
Thanks.
lecture A, Unix system calls part 2. It's not in order in Moodle, it's all the way at the bottom,
Because I think it's PDF.
because it's a PDF.
Only because the other one started with us. Wait, you know what? It's not like.
Okay, guys, we now have another function called pipe.
Oh, that's pipeline.
No, you're right, the pipe that we saw is well, on the command line, you write a pipe. And then it does all its magic.
Yeah,
The pipes across,
Right now?
what?
Are we doing this lecture now?
Yes,
Awesome.
so
Here winning.
when you type that pipe in your command, how does the shell actually implement that? That's just a line, that's just a single line. The line doesn't do anything, it's just a line. We need a system call to enable this behavior.
Okay.
So we have a system call called pipe. Pipe creates a pair of file descriptors. So we learned about a file descriptor with open and close, those are file descriptors. So now we're going to create a pair of file descriptors. That's why it takes an integer 2 here, Dafka 2, because it creates exactly 2 file descriptors. Why 2? Because a pipe is essentially like a file that you're reading to it, you're writing to it, and you're reading from it. It's kind of like a file. This is the way I like to describe it. After years of thinking about it, it's a file in memory. It's not a file on the disk, it's a file in memory. And it allows me to read and write to it. It's also a little bit different from a file because as soon as I read from it, whatever was there is gone. So it's like a pipe of water, like water flowing in a pipe. When you drink the water out of the pipe, there's no water there anymore. So again, let's go to the function slowly. The pipe creates a pair of file descriptors pointing to a pipe I know, which means a file, and places them in the array pointed to by file des. This is file des. File des 0. In other words, we get 2 numbers. One is held in location 0, one is held in location 1. The number in location 0 is for reading, and then the one in location 1 is for writing. So for example, if I would create a pipe, what number do you think would be put in? If I had nothing, if the first thing I did in my program was to create a pipe, what number would we put in file des 0? Well, we know that file des 0, that in the file table, standard out and is 1, and standard error is 2, and standard in is 0. So what would be the lowest number pipe? What would be the lowest number file descriptor available? 3. So 3 will be in this location, and 4 will be in this location. Those are the file descriptors. On success, 0 is returned. So the return value, this integer here, is a 0. On error, it's -1. The pipe has 2 sides, 0 referring to one end and 1 referring to the other end. Always write to the 1 and read from the 0. That's what I said before. Important note. When one writes to a pipe.
Is that referring to the 2 numbers in the pipe that you
Yes.
passed? So the first number you pass.
What do I receive?
What?
This is a blank array.
Yes.
It has, and then it fills it in.
Oh, it's a blank array. I allocate memory for 2 file descriptors.
Exactly. You just
And then
create an array, an int 2.
Okay, and the first one will be my reading and second one will be writing.
Yes.
Got it.
When one writes to a pipe, it may be open for read. And you think about this very simply. When you write, what's the normal order of writing and reading? First you write and then you read. You're not going to read something there's nothing there. So the normal order is write and read. So when you write to a pipe, it may be open for read. But when reading from a pipe, you really need to close the pipe. Depends exactly on the circumstance. It's a little bit complicated. But I'm just saying simply put, we must remember to close the right side in both processes. What it means is like this, that because we're going to make a fork. We're going to make a fork and a pipe together. And then we may have 2 processes. They both need to finish writing before I can read. That's what I'm saying there. Okay, let's do a demonstration of a pipe. And here is a simple example. In order to create a set of pipe file descriptors, we will call the pipe function. In our example, we'll put a simple string into the pipe and then read it out, 1 character at a time. So what do? First of all, int fd2. That's 2 integers, nothing in them, they're blank.
Yep.
Then I say a string hello friend. Then I have a character. That's going to be obviously where I read into. I just read it byte by character, just for the sake of example. And now I say pipe FD. I create a pipe. Now I gave it that FD. So there's an FD0 and FD1 in there. Now I say write, because that's the normal order, you write to a pipe, write to FD1. And I use that write that we learned today. And I give it the string length of string, because the string length of string is going to be, let's say, 13 or something. And the string is exactly what I want to write. So I'm going to write exactly 13 characters into the pipe. Write the string into the pipe. Now I do by close. I close the right side of the pipe. Now I don't close the whole pipe. I just close the FD1. Because I'm saying I'm finished writing. What does that technically do? It's also many years of thinking about it. I probably could have just read it on ChatGPT, but there was a time before ChatGPT. What this does is it puts the EOF into the file, the end of file. And by putting a close there, I indicate, like writing Control D, I indicate this is the end of the file. So now he knows that after hello friend, enter new line doesn't end the file. That ends the file. Now I read from the FD0 and I put it into this character. Single character, I read how much? 1. Now this has to be in a loop because otherwise I'll just read it once. I'll just read one character. So I read 1, I print the character as a C, a character, and then I go back to the loop. The loop will keep going as long as read does not return 0. Now read will return 1 every time until it gets to when it hits the \n, it'll return 1. And then after the \n, there's an EOF, an end of file. So it'll return 0. If I wouldn't have closed it, then there would not be an EOF in there. And this read would hang. What do I mean by hang? It would just sit there waiting. It would say, maybe more water is going to be coming. I haven't been indicated that I reached the end. That I didn't reach the end of file. Maybe, because remember, it's like a stream. Maybe there's more data going to come into that pipe. I don't know. So the read will hang here. It won't return anything. It'll be a zombie. I don't know. What's a zombie? It won't be a zombie. This example does not demonstrate any useful use of the pipe. This is just to show technically how you can do it.
Okay.
Now I read every character, printed a new line, closed the other side of the pipe, and I'm finished.
Awesome.
Again, I just want you to understand that if I didn't do this end of line, the while loop would go on forever. Would just sit there. That's we call that function read a blocking function because it blocks, it gets stuck. Unless it won't return an error. It'll just wait. Here is an example combining pipe with fork, and this is more useful. This is allows for communication between two processes. Because we'll see what we're going to do. Yeah.
We don't need pipe. It's just a helpful way of making 2 pointers, basically, right? I could have made them myself. These places in memory, these descriptors, right?
You could have created a file and then written to the file, and the other process would write to the file.
That's what we just did, no? That's what like pipe
Yeah,
does.
exactly. But we didn't create an actual file. See, there's nothing on a disk. I can do this without a disk.
That's what you said in memory. Okay.
That's why it's a file in memory.
Memory, you said. Very nice. Very nice.
Okay, so here is the file descriptor. Here we have our various variables. Here we do pipe. Now we created a single pipe here, right? Then we do fork. So I want to draw a picture here just to understand what's going on here. When we do a fork after having done a pipe, how many pipes do we have? Do we have 2 pipes? Do we have 2 pipes? He says knowingly.
No.
No, we do not have 2 pipes. We have 1 pipe because a pipe is like a file. Just like if I would create a file and then do a fork, the file doesn't, I don't have 2 files, I have 1 file. So here's our pipe.
Oh, it looks kind of like a pipe.
Yeah, and now we have FD. Which side is the writing? 1, right?
Writing is 1, yeah.
So FD1 is going here. And FD0 is reading from the pipe. So we're putting things in and reading. But when that's what we did at this point. When we did fork, we now have every variable that was before is repeated. So we have another FD. This, let's call this the parent. And this is the child. And he also has an FD1. And he also has an FD0. And this is pointing here, and this is pointing here. And the basic idea is that, let's say, if we want the child to talk to the parent to talk to the child, then the parent will write, we'll close this guy, we're not interested in that. But we'll keep this one open, he'll write, and then here we'll close the parent. This is also the parent, and this is the child. And this will be open and this will be open, but these two will close off. And then the child, we have a single pipe that is a conduit between two different processes. So here in our fork, we just did a clever little thing with switch to check if the fork is 0, then it's the child. And if it's really, I should have checked for -1, but whatever.
Is it?
If it's the child, no, one fork. Switch. I did a switch on the fork. So the value that gets put in PID, I'm just doing a switch on it. So it's like, it could be 0, it could be 1, or it could be any other number. So I do 0, case 0, and case default. Default means any other number. I really should have checked for -1, I didn't, but it doesn't matter. Anyway, so I do close on the read side. This is the child. So the child is going to do close here. See, he does close FD0, but that's not the other FD0, that's FD0 by the child. And now he says write on his FD1. So he says, hello, father. And the child writes, hello, father. And this goes into the pipe.
Why does the father not write that also?
No, the father, at the same time as this is going on, then he does close FD1. He finishes, he closes his side, he closes this.
Who does?
This is a child. Then this break. What does the break mean? The break means skip the default. But the default is the father now. So the father is saying close on FD1. So he's saying close this, because he's not interested in writing. And he says while read on FD0. So he's going to be over here reading on FD0, one character at a time, just like we did before. And he can print out that character, and the child has written a message to the father. Now, this is this is still building up. This is just a simple idea of a child talking to the father. All right, we're going to stop there.
I don't think I understand. Well, why switch PID equal?
Well, you can do a switch on anything, and this, if you think fork equals PID, there's going to be a value here, like 0 or 753. So I'm doing a switch on that value.
It's not an assignment.
It is an assignment.
So what's it evaluated as 1? As true statements, PID equals.
No. No. It's going to process what's in the parentheses first, and there'll be the number there, and then it'll check that number. It'll do a switch on that. I hear what you're saying. I understand what you're saying, but no, this works.
I think it's simple stuff, but it doesn't.
This works. Anyway, the point is, it's just a trick. I'm just being clever here. Could have done if you could have done this as a separate line, and then write if PID equals 0, then I'm a child, else I'm the father. I just did it in one line.
That's the one is the father.
Else is the father. 0. If the PID equals 0, then it's the child. If else, it equals the father. I should really check for -1 also, if the fork didn't work. Why would the fork not work? Why would the fork not work?
No processing.
There's a limit to the number of processes you can have. It used to be 64,000. I think now it's much more.
The sort of key line.
There's no more, the system doesn't allow more processes.
At the
Case one,
Case 0 and default.
Ah,
I was trying to, I was getting there.
All right, we have to learn a few more things to really understand how to do the targeal of the
six,
of 6.
the big
Yeah.
shell.
No,
six.
even yes.
Big shell, not mini shell.
Oh.
I call them shell. Thank you.
Yeah, you should write. You should know enough to do a simple shell now.
Yeah.
The simple shell, for that you needed. Well, did we learn exec? Oh no, we didn't learn exec v.
We don't know, so we can't do this.
Maybe we'll use this next. Maybe
Wasn't that one already?
we didn't learn exec v. Let's take a break now. Take a break now.
I think that was due last week.
No,
What?
but last week. You said we don't have enough time to do it, but it was due last night, so.
I know, but what did you do?
Can we extend it and then do it next week?
Professor, if we finish lab 5, is it video? Yeah, if you finish lab, how did you finish lab 5 without me teaching it?
I watched a YouTube video about it. Very resourceful.
They go real smart.
Yeah, you can go if you finish lab 5.
I'm gonna take attendance anyway.
I took attendance.
Okay, thank you.
But somebody came late.
Stack your laptop and.
Yeah, me.
I have to.
Guys, 20 minutes. You're 11. Oh. Always like something. And they finished on the email. It said on the instruction that you can do it in pairs. Yeah, so I worked with submitted. Yeah, submitted last night.
We submitted it, and it was amazing.
Yeah.
It was amazing. We totally killed that.
Yeah, that's what you used to do.
Yes. No, it said we could, there was one that I could use.
You couldn't use
Yes.
XXVP. Yes, one of them used XXZ right there. You know what we couldn't?
Yeah.
So we just investigated on that. That's what we. Very good. It's just like a wonderful targeal because.
It was a very cute assignment. Yeah.
Because you're doing something that actually is you. That, you are writing. Yeah, that's what we knew that the STR taught. You needed the. Then finally. I know it's second. So I always curse myself. Whenever I say, "Oh, I know this very well," then I. Yeah, I should never say that.
Yeah, we spent
I
our
set
time.
myself up.
Yeah, that's what happens. All right, excellent. Have a great day.
Okay, well.
You should learn to play differently.